Good morning, ladies and gentlemen. Assalamu alaikum. My name is Sabah Nisa. On behalf of University Institute of Information Technology, a very warm welcome to Honorable Vice Chancellor, distinguished guests, respected faculty, researchers, and students. Before I start the formal session, let's begin this morning with the name of Allah. I would like to invite Hafiz Muhammad Faisal to recite 2 verses of Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يا أيتها النفس المطمئنة ارجعي إلى ربك راضية مرضية فادخلي في عبادي وادخلي جنتي صدق الله العظيم.
Respected guests, today I would really like to appreciate all of you for your presence and interest in this special event, first international workshop on applications of artificial intelligence and IoT. It gave me pride to share with you all that Worthy Vice Chancellor, Sri Meher Ali Shah, Arid Agriculture University, is known for his venture that we recognized in the university. The most obvious contribution, Dr. Kamruzaman, took special initiative in the advancement of the research program and led our team of academicians and researchers to successfully develop a special research program. The endless effort in improving the infrastructure for the betterment of the IIT is a kind gesture of the Worthy Vice Chancellor. The most recent and remarkable contribution in his keen interest in strengthening of lab was providing conducive learning experience in UIL. Upgrading of incubation center was also the vision of Dr. Kamruzaman, and we are thankful to him. I would like to mention that the Vice Chancellor is committed to provide first-class education and research opportunities to our students and faculty by initiating multiple mega projects of worth rupees 5,000 million. IT is an essential part of these mega projects, having blend of digital systems, artificial intelligence, Internet of Things, data science, and big data. I would like to request the Vice Chancellor, Professor Dr. Kamruzaman, to share his views and formally start the proceeding of the works.
Dr. Associate Dean, Edward Island University in Canada, Dr. Dean Randhawa, University of Prince Edward Island, Sattam Dean Randhawa, IBM Canada, Dean Director Students. I warmly welcome our all distinguished guests from Canada and different countries this morning and afternoon participating in this conference. So, last 2 days, our guests are with us and delivered lectures on application of IT and data science in agriculture. As we know, this IT last few decades, IT application in agriculture to develop advanced technologies is part of our agriculture curriculum and research and development. Without IT, we cannot move forward. You have seen that we established the Precision Agriculture Center in University, and all the component, all the equipment we have or machines, those the major part is software and programming, algorithm development, that are machine learning systems, deep learning techniques. We need a specialist in IT. So we are lucky we have an institute, this IT institute in our university, and very talented and experienced faculty and students. And Dr. Yasser is leading this UIIT and UIMS, and we have seen that job here. Many companies and industries are interested to work with this institute and university. So, but unfortunately, I was in agriculture university, Hyderabad, so not much interest from our agriculture side. And we have the universities, Iran Agriculture University, and Pro Vice Chancellor, I think, Chancellor just right, and Dean and Director, or all are from agriculture faculty and engineers. So, but without this technology, we cannot improve job. We cannot quality. We cannot export our quality. And this is a opportunity. And for this university especially, we are leading in innovative technology development and implementation. And first drone is donated from China. Our Dr. Tahir, he brought to this university. No university at that time has that capability or capacity. We have that center on our technologies in phase one, and our team, senior agriculture team, Dr. Jahantir Tima, Dr. Naveed Tahir, Dr. Shoaib, and their other colleagues, they have been working day and night to develop those technologies, and we were able to demonstrate before time. The project is for 3 years, but after 2 years we demonstrated, and we are going to demonstrate in different so any user can use it. And we have been working on linkages between academia and nationally, internationally, because of this COVID-19. So our many guests from North America, Europe, or other countries, China, Japan, could not come. But now we are very grateful to our these distinguished guests. They came all along from Canada, and hopefully more is coming from different countries in the coming weeks to get those links. So you will see today these presentations how the integrated teamwork, because this is an integrated teamwork. Only agriculture or IT or engineering cannot develop these technologies. We need agriculture. And I emphasized on during this senior agriculture conference at Erosion and in Hyderabad University during the seminar that demand should come from agriculture faculty. So entomologist, pathologist, zoologist, agronomist, they come and ask them, we need this technology, this technology. Then engineers and IT people sit together and work on that and develop those according to their needs. So with these technologies, we can save our agriculture resources, and we can protect our environment, reduce cost of production. And one question was that how this same agriculture contribute in GDP. So we tested, evaluated this team, agri-engineering team, developed Dr. Tahir and his team one device attached with very simple drill, traditional Rabi drill. So and improved 8% crop production with that equipment. And now auto steer, if we use that, that is proven 10% increase in yield. And same way, efficient methods of irrigation and drone technology is very popular now. and private industry started using that drone. But we again, this university is leading it, and now hopefully our team will have next week drone for seeding, not only spray, for fertilizer, granule fertilizer, and spray. So and they got app, but that is again IT people. We need to work on that for target application and for this remotely controlling those drone. And but again, I am encouraging it, and hopefully some of our faculty members from agriculture faculty sitting there to convince, to change their mindset that we need innovative technologies to improve crop productivity. And again, Malik Saab is there now. Malik Saab, ये देखे इन्होंने ना सारे लेक्चर रूम कनेक्ट किए हुए हैं, ये लाइव सारे स्टूडेंट बैठे ना पूरे के सेंटर में, इंस्टीट्यूट में ये सेमिनार देखेंगे। तो हम एग्रीकल्चर में क्यों नहीं कर सकते हैं? क्योंकि ये सारा वो हमारे वो टवाना साहब, मुझे वो बात बड़ी पसंद आई है, फाक टवाना साहब फार्मर है, तो उन्होंने कहा कि मौलवी साहब से उन्होंने कहा कि मौलवी साहब हलवा बनाया, तो उन्होंने कहा सानू भी, उन्होंने कहा ਤੁਹਾਡੇ ਲਈ बनाया, उन्होंने कहा ਤੁਹਾਨੂੰ भी लेकिन एग्रीकल्चर वाले नहीं लेना चाहते हलवा, नहीं लेना चाहते। लेकिन डॉक्टर साहब कह रहे आप ही खाओ, आप ही खाओ, अब तक खा ही लेना। लेकिन ये असली मैंने खा के मैं डॉक्टर यासर साहब ने क्या मैं क्या कि ना सुनना ना सुनना, एक बारी सर तक देंगे, दूसरी बारी बट्टे मारेंगे, निकल जाओ सानू टेक्नोलॉजी चाहिए, तीसरी बारी सानू शायद लेक्चर रूम चवा लेंदे, चौथी बारी असली ने गल सुना देनी है, ते पंजवीं बारी असली जड़ा है इंशाल्लाह कामयाब हो जाना है। 3.5 साल हो गए, 6 महीने के अंदर असली ने सुना देनी गल, और सुना रहे हैं ये तो ये लेकिन इनका भी जो इंटरेस्ट है ना एग्रीकल्चर में, असल में ना मुझे जो नजर है ना प्रॉफिट मार्जिन थोड़ा तो सेटिस्फेक्शन तो है ना कि देखो आप 4 करोड़ वहां वो बैठी है फ्लड में, तो उनको भी हमने वो जहाँ फ्लड नहीं उन्होंने अरेंज कर एग्रीकल्चर वालों ने, तो ये मिसमैनेजमेंट होगी, सब कुछ होगा, लेकिन इसके बावजूद हमारी ड्यूटी जो है वो हमने करनी है। अगर हम प्रोडक्टिविटी, मुझे कई साल हो गए थे ये मैकेनाइजेशन पे बात करते थे, डॉक्टर साहब बड़ी बड़ी मीटिंग में जाते हैं तब वो फर्टिलाइजर और सीड इम्पोर्टेंट है, नो डाउट। उन्होंने कहता था जी फर्टिलाइजर भी ले आए, सीड भी ले आए, सब कुछ फर्ज कर ले, जो कि अभी नहीं हुआ, कर हो गया, लेकिन आपने जो आपके पास ड्रिल नहीं है, मैनुअल सॉइल की जर्मिनेशन पूरी नहीं, प्लांटर देखिए वो राइस में कितना कामयाब हुआ वो जापानीज का, और उससे पॉपुलेशन डबल हुई, वो जो पॉपुलेशन वो वाली नहीं जो हम कर रहे हैं डबल तो ताकि वो तो ये ना वो मशीनरी, फिर आप देख लीजिए अगर आप टाइम पे, और वो भी जो है ये अब ऐप बनेगी, बन रही है कि कब स्प्रे करनी है, कब इसको इरिगेट करना है, कितना करना है, जब तक ये टेक्नोलॉजी नहीं आएगी फिर आप सारा कुछ कर लिया, वो भी हो गया। हार्वेस्टर 40 साल पुराने, 50 साल पुराने, 25% तक लॉसेज हैं, वो हर मीटिंग में डॉक्टर इकरार साहब उन्होंने फार्मर साहब बुलाए, तो प्राइम मिनिस्टर टास्क फोर्स पे, अब जो है ना हर फोरम पे वो कह रहे हैं जी बताएं कैसे वो हार्वेस्टर इम्प्रूव करना है, वो माइंड चेंज करना कई साल लगे। तो इसी तरह प्रोसीजर एग्रीकल्चर टेक्नोलॉजी पहले कहते हैं ये गलत करने के लिए, हालांकि नहीं, ये आप देखते हैं कि आपकी आईटी जो है ये हर शोबे में है, ईच एंड एवरी डिपार्टमेंट, तो यूर कंट्रीब्यूशन, लेकिन एग्रीकल्चर में आपके इंस्टीट्यूट की बड़े अच्छे प्रोजेक्ट मैंने देखे, उनकी डायरेक्ट एप्लीकेशन है एग्रीकल्चर में, तो आप ये प्रेजेंटेशन देख लें, देखने के बाद ना मुझे आप में सभी ये एक 4-5 वॉलंटियर आए, वो हमें कहें जी कि हम एग्रीकल्चर में ये काम करके दे सकते हैं। अब हमें जरूरत है इमेज प्रोसेसिंग, फास्ट इमेज प्रोसेसिंग। ड्रोन जो है जब फ्लाई करे तो साथ ही इमेज प्रोसेसिंग करके तो कुछ है स्मॉल एप्लीकेशन जो है तो वो जो एक्सपर्ट हैं तो डॉक्टर साहब आपकी इमेज प्रोसेसिंग में है तो आप नहीं खिलाते रहेंगे साथ देंगे पता। और इमेज प्रोसेसिंग में कौन है? तो डॉक्टर आपका नाम अभी साहब आप ही, तो वो जो इंटरफेस को बनाते हैं वो कौन है? वो भी आप करते हैं या कौन भी है?
वो भी हम करेंगे,
सब करेंगे। ਤੁਹਾਨੂੰ ਪਤਾ ਸਾਨੂੰ ਪਤਾ ਸਾਡੇ ਨਾਲ ਹੀ ਰਹਿਣਗੇ ਸਾਡੇ ਨਾਲ ये जो है ना जी देखिए वो बड़ी अच्छी बात है, हमने साहब ने भी विजिटिंग जो है ना काम किए हैं तो ये आज सुबह वो हमारी जो तो उन्होंने वॉलंटियरली ऑफर किया जी कि मैं कोर्स पढ़ाऊं। तो ये देखिए ये बाकी भी जो फैकल्टी है उन्होंने भी एक कोर्स 2 कोर्स, उससे कोई फर्क नहीं पड़ेगा, लेकिन यूनिवर्सिटी को बहुत फर्क पड़ेगा। एक तो क्वालिटी का कि विजिटर के पास लॉन्ग टर्म प्लान नहीं होता, ये नहीं कि वो काबिल नहीं है, वो प्लान नहीं कर सकते। तो दूसरा ये है कि हमारे जो अपने फैकल्टी हैं वो जब वो स्टूडेंट के साथ इंटरेक्शन ज्यादा है तो ये एक्सरसाइज इस दफा की है तो चाहे वो 1-2 जगह पे वो एंथ्रोपोलॉजी शायद सब्जेक्ट एक तो है यहाँ हमारे पास सामने है, बाकी हमने कोशिश की है कि स्टाफ भी पूरा हो जाए। लेकिन आप देखें कि ये आईटी इतना इस दफा वो एडमिशन का डॉक्टर साहब को पता होगा, यासिर साहब को, और हमारे पास भी जो आ रहा आईटी पूरी दुनिया में ये तो इतनी इसकी एप्लीकेशन है। तो ये आपने जो है ना ये अप्लाइड जो आईटी पार्ट है, इसीलिए हम ये हमारे जो बाहर से मेहमान आए हैं तो ये एग्रीकल्चर के नहीं है। तो ये स्पेशली जो डॉक्टर एग्रीकल्चर इंजीनियरिंग PhD मास्टर एग्रीकल्चर में है, बाकी तो जो है ये आईटी से सारा इनका, लेकिन आप ज्यादा बेहतर जानते हैं अप्लाई करनी है टेक्नोलॉजी। यही मैं ये डॉक्टर साहब है बायोटेक्नोलॉजी के मैं जाता हूँ, ये हेल्थ की बात करते हैं, बात ये है कि पहले तो फूड आएगा तो एग्रीकल्चर में वो टेक्निक इनके पास ऐसा नहीं है। तो इंशाल्लाह ये बात सही होगी, लेकिन हम सब ने मिलके वो हलवा बनाना है और जबरदस्ती डॉक्टर साहिब साहब और ये डॉक्टर साहब बैठे हैं लेके एग्रीकल्चर वालों को खिलाना है। तो आएंगे इंशाल्लाह, पहले उनका पेट खराब होगा थोड़ा सा तो इंशाल्लाह ये आज की जो बात है वेरी प्रोडक्टिव और स्ट्रॉन्ग लिंक जो हम बना रहे हैं उसमें भी मदद मिलेगी। इंटरनेशनली इंडस्ट्री के साथ आपका लिंक है, एग्रीकल्चर इंडस्ट्री के साथ भी हम काम कर रहे हैं बहुत ज्यादा ये स्टेक होल्डर्स को मिला के। तो ये जो लिंक है क्योंकि इंडस्ट्री फर्स्ट स्टेप है टेक्नोलॉजी आपको पूरा डेवलप करनी, उसमें सारा साइंटिस्ट रिसर्चर मिलके इंटीग्रेटेड टीम के साथ वो बनाएंगे, फिर कमर्शियलाइजेशन इंडस्ट्री हमारे साथ आएगी इंशाल्लाह, वो आ रहे हैं और हमारे अपने स्टूडेंट भी एंटरप्रेन्योरशिप की तरफ जा रहे हैं। तो एंटरप्रेन्योरशिप में भी बहुत ज्यादा जरूरत है। तो उसके बाद जो है ये फिर जब ये हो गया ना इंशाल्लाह इंटीग्रेशन हो गई, इंडस्ट्री आ गई, गवर्नमेंट जैसे हम कर रहे हैं मैकेनाइजेशन के लिए, तो फिर ये जो है इंशाल्लाह पहले नंबर पे रहेगी टेक्नोलॉजी, इनोवेटिव टेक्नोलॉजी, तो उस पर हमारा जोर है। तो इंशाल्लाह वो पॉजिटिव रिस्पॉन्स आ रहा एग्रीकल्चर में भी ये मोटिवेशन जो सारे मिलके सीनियर करेंगे और हो रही है, डील करेंगे। तो लेकिन डॉक्टर साहब एक तो ये देखिए बड़ा अच्छा ऑर्गेनाइज करते हैं ये दूर से ही। तो ये मतलब आपको चाहिए कि हमने अपना एग्रीकल्चर के, इंजीनियरिंग के या फिर कुछ सेमिनार, ये ना मसला एक और है कि अगर आईटी वाले ऑर्गेनाइज करते हैं ना, बाकी समझते हैं कि उनके लिए ही है, हालांकि फिर वो बात आती है कि ये इंटीग्रेटेड वो ऑडिटोरियम में भी बार-बार ये रियलाइज करता रहा कि ये इंजीनियरिंग वालों का नहीं है, वो लीड कर रहे हैं, लेकिन आपके लिए है ये आईटी का, ये जो है ये एग्रीकल्चर के लिए है। लेकिन ये तो आपके इधर नहीं आते, तो आईटी वाले, यूआईएमएस वाले तो नहीं आते, तो आप आ जाए। तो ये सबके लिए, पहले तो जाति आपको सेमिनार वर्कशॉप करते हैं ना, ये एडवर्टाइज करेंगे कि ये सबके लिए है, तबलीग किसी एक के लिए ना हो, सबके लिए। तो लेकिन ऑर्गेनाइजेशन को ये जो ये सारा सिस्टम है, ये तो फ्री में खर्चा नहीं है, इस पे जिसमें ज्यादा हम बेशक वो बड़ी बड़ी लगा लें दूसरी तरफ से नेक्स्ट टाइम। तो ये लाइव उधर वो शेयर में चले, वो डिफेंसिव वाले चौक में चले, जो खड़ा होकर सुन सकता है। तो इस तरह ठीक नहीं, बिल्कुल ठीक है। थैंक यू जी, थैंक यू।
I would like to introduce the keynote speaker, Dr. Izzat S.N. Farooq. Dr. Izzat S.N. Farooq is working as an associate professor at the Faculty of Sustainable Design Engineering, University of Prince Edward Island, Canada. Dr. Farooq's research focuses on fundamental understanding and development of state-of-the-art precision agriculture technologies for Eastern Canada's agriculture industry. Dr. Izzat is actively working on machine vision, remote sensing, and digital photography technique for mapping, artificial neural network, deep learning, analog and digital sensor integration for agriculture equipment for real-time soil, plant, and yield mapping. Now I would like to invite Dr. Izzat S.N. Farooq to present his talk on artificial intelligence for applied science.
Screen sharing log.
Morning, everyone. And agriculture university in my Today I'm going to start a little bit about application of artificial intelligence and machine vision for agriculture. And as Dr. Zaman mentioned, my background is in agriculture engineering. So we apply these technologies that I did instructor. Can you hear me okay on the back? Yes. Today, as I mentioned, we are going to talk about some of the applications for deep learning and artificial intelligence for agriculture. So why agriculture? First of all, as Dr. Zaman mentioned, today's agriculture needs to be digital. So in order for upcoming generation to have interest in agriculture, we need to develop smart systems. Because the young generation, they like iPhones, they like apps. So if we are doing traditional agriculture, that's not going to work. And we will have a serious consequences in terms of capacity. So that's why these technologies need to be integrated, and we need to work into multidisciplinary teams where IT, agriculture, computer science, also mathematics. So we work in a team to develop systems which are for the benefit of end users. So as we all know, agriculture, our population is growing. We need more feed, food and fiber, and also the land is shrinking because of urbanization. So that's another reason we need to be smart. We need to produce more from the less land, and we need to develop those systems. And another perspective from the climate change. So over the past 50 years, so greenhouse gas emissions have been doubled. And now, how can we develop these systems that we can optimize our resources at the same time, make the management practices more efficient, so that we are contributing less to the environment in terms of the greenhouse gas. So since it is a IT crowd, so Just to give a very brief definition, what precision agriculture is. Precision agriculture is a science that encounters the variability within the field. And that variability could be in anything, whether that is a soil, crop, yield, even weather parameters, how we can manage that, how we can optimize that, and also not only to detect and manage, also apply our inputs based on that for the resource optimization and so there could be different sensors which we can use for precision agriculture. Obviously, those sensors are georeferenced, and once that data comes, then that's where the IT starts. That how to manage that data, how to bring that data into a farm that we can make some best management practices to tailor best decisions for environmental efficiency, for farm profitability, at the same time reduce environmental risk. On this slide, there are various sensors, and there are many more which we can use for agriculture applications, whether that is applying height mapping, yield mapping with the load cells, also soil sensing, and these days drones are very common for non-destructive measurement. So I'm going to bring a few examples here to illustrate the application of these technologies and the application of artificial intelligence and deep learning that we have done. So obviously, the first step when we go into the field, we need to look into how that field looks like. What kind of variability we are dealing with? Do we have any historical data which we can build on? When I say historical data, that is 5 to 10 years data. And now, when we have a history or database, then how we can manage that data? How we can present that data in a form that an ordinary person or grower can understand. For example, if the IT builds an application for irrigation, that has to be on the smartphone because the user doesn't understand how it works. All they need is touch and feel. So this is one of the sensors we use for soil sensing. We call it a dual sensor. We integrated that with the slope sensor and developed the management. From this slide, you can see, so these are the management zone. Obviously, there has been data processing behind the scenes in GIS and machine learning models to develop this map. And you can see the red areas, those are least productive areas, yellow areas are moderately productive areas, and green areas are highly productive areas. Now, the idea was to do your best at these. That we know that if the areas are not strong enough, why to put inputs at the same rate as the other rate. Also with the seed, how we can manage the seed rate, and also management practices for optimization. So this is one of the examples I want to present. So this was one of the field in Prince Edward Island. We selected that field, we mapped that with the dual EM and slope sensor, integrated that data, processed that data, and also and then the next step, and obviously we went with all of these strategies in your best objective. So now when that was done, so we had a control section where we want to go with a traditional practice, and then we have also the variable rate section where we want to change the rates based on the productivity potential. So this map gets fed to the variable rate applicator. So and the potash application was performed based on the variable rate and compared with the uniform application. So at the end, we collected the yield map. So this is a yield map from the load cell, and you can see the red areas are the red dots, they represent the low yielding areas, and the green dots, they represent the high yielding areas. And this map was overlaid over the productivity zones that we developed from the sensing and data processing. And then we found that we were able to increase about 300 pounds per acre just with a potash application with no additional cost. And then the idea was that at the end of the day, this technology has to be profitable and it has to make sense. So we did the economic analysis for that, and we found that this application resulted in $21 per acre as profit, which is quite significant for potash application. And because we reduced the production cost, at the same time we generated more profit. So now I want to give one example for the AI applications for the drone imagery. So obviously, when we have drones, so we have to plan the flight, then we need to collect that data, whether that is NDVI, using multispectral sensor. our soil temperature map using the thermal sensor. And then we can process that data using different softwares which are developed by the computer scientists. So this is one of the examples I really want to show. So this is about the soil erosion. On the left-hand side of the top, you can see a picture which was after the image processing and geotagging. So you can see the erosion path. So here is the erosion path that where the water will. We are an island, and then we have a serious erosion issue. And then after everything gets planted, we don't see any difference on July 4th. And then we did a thermal imaging on the same field, and we saw that where we had the erosion issue, that the soil temperature was significantly higher, and it was higher about 10 degrees compared to the rest of the field. Why that temperature was higher? Because the soil was not productive enough, and it does not have organic matter to retain that moisture. And then we overlaid the yield, and we found that those areas were not profitable. So then it boils down to profitability mapping. That do we really need to plant this field uniformly, or because it's not going to profit? And the stronger areas will end up covering the weaker areas. So another example with a SWOT map. So we have the productivity zone. So we have NDVI map, which we process, and then field map. And we got about 80% comparison. And we found that there was about 80% matching. That the least productive areas were not generating enough heat, at the same time they were poor performing. For example, on the left-hand side, if you can see my cursor, on the bottom, so those are the red and yellow areas. If you look at the NDVI map, not doing well. At the same time, these areas were not producing. So then another application from the same data, image translation using artificial intelligence models. That once we have RGB imagery, so how we can process those RGB imagery to NVIDIA. So then we use artificial intelligence models. So in this particular case, we use fixed-to-fix HD model and fixed-to-fix. And those are we didn't develop those models. We just used those models. Sorry for the technology mess up. Anyway, so we didn't develop those models. We used those models for the image translation, and we were quite successful with those. And we have a publication that is currently in review. So then we did try a little bit on the variable rate seeding, where we compared the traditional spacing with the lower spacing and higher spacing based on the productivity potential using the SWOT map. So this is how the SWOT map looked like after processing, and then we captured this imagery to do the plant count. And you can see the dots which are right on the plants. We counted them. We look at the planting density. We look at the emergence rate. And the idea was again see whether those management were working and how well they were performing. So then at the end, we analyzed the yield, and we found that the tighter spacing, which was lower than the traditional in the high yielding areas, so that outperformed with when it compared to the standard spacing. And also in the weaker or low productive areas, we spaced the potatoes out of the stick, and they were the yield was significantly higher than the traditional. Another application for artificial intelligence and machine learning. So that was the development of Sprayer, which is our own database with over 15,000 images, early morning, late evening, cloudy, partly cloudy, sunny, all kind of conditions, and with the various combinations. And we talk about healthy plant, disease plant and soil mix, feed and plant mix, all kind of possible combinations we can think of. Once that database was built, obviously we labeled those images to find out what is what, and then we trained and validated the deep learning models. We use TensorFlow for that, and then once we lab calibrated that and validated that. So then we deployed those files and then we integrated that into a stream system. So this is the CAD model which you can see. So it has 3 cameras. So it covered each row and in potatoes, and then goes into the CAD process and gets all those deep learning deployed models, and then we find out what is what, and then it activates the novel. So this was one of the lab testing where we checked those targets and non-targets. So target in this case was the lamp quarter, and then the non-target. So click on the lamp. And then when we look at the savings, so our saving in any case was over 40%, which is huge. So that means you can reduce your production cost by 40%. So which is actually gain for the farmer, and if we are not compromising the production. So this is one of the video in the field. I don't think we have time, so I'm not going to spend any time on that. So the next application, and this is the last application, is the computation of evapotranspiration and using artificial intelligence. So we use the deep learning models to estimate the crop water requirement. And then we compared that with the FPO56 method, which is very traditional, and then Penman mounting method to see how accurate we were. And in any case, we were accurate over 90%. So that means using weather-based prediction, that is relative humidity, temperature, and precipitation, we can come up with a crop water requirement to tailor our irrigation.
जी स्लाइड आगे नहीं जा रही थी, मूव नहीं कर रही थी, वो दोबारा शेयर कर रहे हैं।
Okay, then we looked at the entire year. There, we wanted to see how we can calculate the evapotranspiration using here. And then this is the evapotranspiration model prepared for the entire year. And we were pretty accurate. So now based on that, and we had the crop water requirements determined at different stages. Then we install an irrigation system. We provide the irrigation system back. And then before we went with that, so we are range back, like Farani in Prince Edward Island. Because of the climate change, the rain patterns were shifted. So the red line is our requirement for the crop, for potatoes. And then the blue hills, those are the precipitation. And you can see in July and August, we were lacking. So we are not meeting the red line. So that's where the province was concerned that we need the sustainability of potato production on Prince Edward Island. Because potato is a huge industry on the island and it contributes towards that farm. But in any case, irrespective of the irrigation system, whether that was drips or sprinkler or the fertigation compared to the control, our yield was significantly higher, suggesting that the supplement irrigation can cope with the climate change and also sustain the potato industry of Prince Edward. So just building on that, so this is the app we developed. So we have over 100 weather stations which are connected on Prince Edward Island, which we control as a School of Climate Change and Adaptation. And now I have submitted a proposal to the provincial government that we can use all these weather stations to calculate the province-wide crop water requirement for different crops to sustain agriculture industry in Prince Edward Island. So that proposal is currently under review, and I'm very optimistic and hopeful that this will be funded. And I have a link here to the climate.ca. So we have a few other apps there. We have the different, for example, there is one app, we call it the warning system app, because we are an island. So when the tide goes high, so we have installed the lighting devices to kind of tell us how much water is going by, whether it's going to erode our island a little bit or not. So that is sort of like a management tool for us. On this website, there are a few other apps which we developed for different times. So at the end, I would like to conclude that we need to work together as scientists, agriculture scientists, IT specialists, computer scientists, and basic scientists, so that we can develop technology for the better benefit of the end user. Once we develop that technology, we need to evaluate that technology and also to see whether that is profitable. We need to develop practices so that we can lower greenhouse gas emissions. And this is important that whatever technology we develop, it has to be user friendly, because majority of the growers, they are not at the capacity or the knowledge where they can teach it. So it has to be in an operation. And then we need to train our students, postdocs, research associate, undergrad, grad student, and so that we can build that capacity. And if we make the agriculture smart and digital, our young generation will have an interest in it. But if we keep going traditional, we will reach at a point where nobody in the young generation will be interested in that kind, because we are in a digital era. At the end, I would like to thank our collaborators for their funding support. Also, my team at University of Prince Edward Island and my collaborators from Dalhousie and University of Florida for their support on these projects. And at the end, I would like to thank you all for being here, and I can take any questions.
Thank you, sir, for your valuable talk on how to implement artificial intelligence on precision agriculture. Now, I would like to introduce Honorable Keynote Speaker, Dr. Gurjeet Singh Randhawa. Dr. Randhawa is an Assistant Professor of Data Science in the School of Mathematical and Computational Science at the University of Prince Edward Island, Canada. His research interests include data science, machine learning, bioinformatics, evolutionary computing, and precision agriculture. He has developed several machine learning and digital signal processing based software tools for data analysis. Now I would like to invite Dr. Gurjeet Singh Randhawa to present a talk on how to choose best machine learning model for real-world data set.
work best. No.
Sorry about that. So technical difficulties around here. I'd like to continue from where we left off. Let's begin. So to start with, all the machine learning pipeline work, I think most of my people are here with that, but I'm still not over it. So we begin with when we have data and we want to analyze it. What we do is first we prepare it for our machine learning model. After getting the data, sometimes it's in a raw form, sometimes it's in unstructured form. So we need to get to a point where we have feature vectors that can be used as a machine learning model. So for that, we need to tackle some problems, like sometimes some fields are missing, some data values are missing. Sometimes we have to get entries. So for that part of the presentation, we have multiple techniques that we use to prepare our data for machine learning model. We can normalize that, we can transform it from one form to another. We can check the validity, or then we can produce the feature vectors that can be used as the machine learning model. Once we have our feature vectors, then the question of model selection comes. That among different models, and every model has different hyperparameter setting, which is the most optimized for our real-world data set. So we'll focus mainly at that part where we have this second part with the trained models, and we have this automatic model selection. And once we have figured out which model works best for our case, then we can just deploy and then check the scoring, check the results. And then towards the end, I'll also show one application of then I'll show the application of some of these models. So model selection, it can be applied at different levels. So one level could be you have multiple models. So you have linear, you have quadratic SVM, you have random forest, you have other decision trees, you have logistic regression. So which one will work best for my case? Second one would be once you have selected a model, it could be the same kind of algorithm but different parameter setting. Because if you are using the 4-vector machines SVM, what degree of polynomial you should use, whether it should be linear, whether it should be quadratic, cubic, or what degree you want to go. So model selection, it can be a mix of these things, or it can be applied with any of these levels. So just introduce a few of the concepts that will be using underfitting, overfitting. Most common problems when we deal with machine learning models. Underfitting is something, say, okay, so before I talk about underfitting and overfitting, I'll talk about different kind of data sets or conditions of the data sets. We have training data sets, which we train our models and we get generalized models. That is the as well, and that can predict something for data in the future. Then we have a validated data set which exposed, and when we train our model, we just want to improve the quality of the setting of the model. We use something for intermediate testing, and that's our validation set. And the testing set is the unseen data that model has never seen. Will directly use based on its learning in the past, will directly use particular labels. When we talk about underfitting, that is something that you choose a model that is too simple. And when we talk about machine learning model, they are nothing but mathematical functions. So we choose a mathematical function that is too simple to define the spread of our data point. And with that kind of data set, we'll get underfitting is really easy to get because we will get very low accuracy the training itself. And same will happen when you will test your testing data set. The overfitting, when we want to increase the complexity of our model, our mathematical function, we want to increase the hierarchy of our polynomial. Then we come to a problem that we force our model to generalize well based on the training data. So it's kind of learn, or I would say cram, whatever is given to us in the training data set, but it won't know the actual pattern. So the model will eventually fail when it is exposed to unseen data in the future. So what we want is something in between, something appropriate fitting that has a model complexity that is suitable for us. That means we can actually run this model for real time. And based on its performance, complexity is not that much, and it can work well on both training and testing data sets. So these are this graph of polynomial functions. You can see as we increase the degree, we are basically going from the straight line to this is say degree 2 in quadratic function, cubic degree 3 and quadratic function. So as you can see, these are different data points of two classes. Say I want to separate class 1 from class 2. And if I'm just using the linear model, I'm looking at the straight line of looking for a mathematical function. That one straight line and trying to split it our data into two focus paths, which realistically is not the case. This is kind of cubic because by quadratic complexity, so degree 2, we have complexity will be to your mathematical function. And this I believe is degree 7 or 8, where you are enforcing your model to overfit on the data so that it can perform very well on the training data set. So this is a case of underfitting. You can see this these dots, these blue points, these are observations, different data points of our training data sets. And they can be represented with this mathematical function that is what is blue line. And model function, that means that the one we are using with only 1 degree, that means one straight line linear model, that represents the straight orange line that represents our machine learning model, which represents the linear equation. And when we use this linear equation and when we try to fit the testing data, these blue points, when we want to map where as close as point is on the straight orange line, we get these predictions just far away from their original label. That's when we know that we have done underfitting. That means it was not working well on the training. It also kind of failed on the testing. Overfitting, on the other hand, we use very high degree of polynomial. Like in here, we are using the polynomial equation with degree 25, and we are enforcing our model, this mathematical function represented by the orange line, where we are forcefully fitting all these points to be on that mathematical function call. And when we use it on testing, it may eventually fail or its performance will decline. That's when we know that our model didn't generalize well, but we forced it to learn our training data set. But if the pattern range even slightly in the testing set, the model will fail. And how we compute the error, that means how far our predictions are from the two levels. That there are many ways to do that. The most kind of one is the mean square error, which is basically the sum of your true levels minus predicted levels. We take care of these differences just to make the numbers positive. And then we are dividing 1 by n because say we have n predictions, and that is your mean square error. So the more the value will tell you, the more the error is. That means you are far from your prediction and you need to fix something in your model. And these are training and testing calls, again representing underfitting and overfitting. You can see with the low degree of polynomials, you will have underfitting, that means both training and testing errors are higher. And as you go at the degree of polynomials, your testing call will show more error. That means model can as well, and it's kind of failing on unseen data in future. So some techniques for model selection, it depends on your data set. So you can have two cases. One case could be you have too much data. And in that case, I would say too much data is good because now you can figure out which one to keep, which one to discard. And nowadays, many fields, I would say, are seen there has been tremendous growth in electronics. Like when we grew up, there were hardly any cell phones. Now, when we carry those, we use tons of data, we use social media, we for any other app. At that time, everything, for example, loving grocery stores, shopping, everything was manually. Today, the cash you get hand feed. Now there are cash systems which are electronic, which are recording electronic transactions. So you are producing tons of data there. Genomics, at that time we were hardly sequencing any single gene. Now we have complete genome, which produces like terabytes of data per second. So how to analyze that data, that's a big problem. And if you have enough data, then you can go for something, some different approach that leads your sampling method. But in scenarios where, say, you do not have historical data, you start on something new, you have only two look at. In that case, you can rely on proven probability. You can just look at some probability-based methods. But when we say the best model, best is something overrated when it comes to the machine learning. Because the definition of best is actually different for person. So we select our definition and say we are not interested in choosing the best, we are choosing something good that is set by the interest of stakeholders. So somebody could be looking for something that they can actually run based on their machine power. So I could have access to a really big supercomputer or a server which I can run much larger than much complex algorithms. Somebody else could have a very simple computer where it's not possible to run the complex models with higher polynomial degree. So it depends on from person to person what kind of model they want to pick. So for that, again, your target question could be, I want something that outperforms the state-of-art method, or that competes with them. Again, so the definition of best or the definition of good depends on who's going to do tomorrow. So as I said, two techniques, simply stating if you have enough data, you will go for resampling method. If you do not have enough data points, you will go for probabilistic bias. And when we go for probabilistic bias, we want two things. We want to increase the performance. We want to check how well the model performs. Mostly that can be done using checking the accuracy of the model or F1 score or other statistical bias. Second could be model complexity, say degree of polynomial or simple model. So we'll be interested in something that gives us higher accuracy as well as the simple computing. So again, it depends if I have an extended system. I may choose a model that gives me 99% accuracy, but that takes only say 5 minutes. Somebody else would look for this that I'm satisfied with only 97. I don't want 99, but I want my work done within few seconds. So that's up to you, to your requirement, how complex you are on the definition of performance and the complexity. So there are a few ways that we can use when we have too few samples to observe in probabilistic bias. These are only few most commonly used Kayak and Bayesian theory-based criteria. And then there are many variants of these statistical bias that are used in reality to pick the best model or to select the best model. AIC, it tends to select the complex models because what AIC is doing is just measuring the information loss. And here you can say K is just the number of parameters in your model. We are taking log of L. L is the maximum likelihood log ratio. That's basically just ratio of your expected and predicted actual values, recorded values. N is your number of data points in the training set. And as you can see, you are dividing it with N. So that means your number is going to be smaller and you're getting information log. So you go for a model that will give less information, and it may end up selecting a complex model. It's not finalizing as you increase the complexity. So BIC tackles that limitation, and it tries to finalize a model that making like that means that have hierarchy of polynomials. And you can see we are not dividing anything, but we are multiplying the log of n with our k was the number of parameters in your model, and then we are subtracting log of our likelihood ratios. So this will pick for something simpler, because as we increase the complexity, this measure is going to analyze the model. Then I'll focus more on resampling models, because these days most of the fields that we deal with, the same agriculture, health informatics, genomics, we have more than enough data. So we have too much data being collected all the time by various sensors or say genomics or different sequencing machines. So the problem is not the lacking of data. Definitely there are some issues with the data pre-processing, data cleaning, which point to keep, which to discard, or fill the missing entries. So that comes under data cleaning and pre-processing. That takes around 70% effort of any data scientist just preparing that data to set up for these models. But once we have data, then how to prepare our model, we can use different techniques. And again, cross-validation is the most popular one here. First one is simple, random train and test of split. That means take your data and choose on training and testing split ratios. So you can say that I'm going to use 30% random points for the training, 30% for the testing, and you can hope that based on the probability, it's highly likely that if you're picking 70% random points, that you'll cover diversity of your data set, you'll cover data points from all the classes. Bootstrapping on this is pretty close to your random complex, but now you pick multiple steps for bootstrap. So you have multiple steps, E equals to the size of your data set, and you pick the data points with replacement. That we say if I have 100 points, I'm going to pick one bag with 100 points. It will be duplicated. So you pick one point, you put in a bag, and then you put it back to your original data set. Then you pick another point, put it in your bag, and then put it back to the data set. So you repeat the process in the time to fill your one bag, and you can have multiple bags. And then you perform your training of your model, learning of your model on all these bootstraps, and then you just take the average and hope that your model has been trained multiple times on different positions of data points, and it will learn well, and it will generalize to learn better. Cross-validation is something that in reality been shown to work best, because say you're doing random splits. It's just lucky guess. But if you're doing 30% of split, just running it for one time, every time you're gonna get different results, because you're random splitting sometimes if you're lucky enough, you're selecting the good data points, you can get 90% accuracy. Other time it can drop to 16, 30. So it's not good at practice to use random splits. On the other hand, with cross validation, you get some game code. Say if I use 10 poles, I'll divide my data set into 10 separate random parts, which are not sharing any data points, different data points. At one time, I will train my model on 9 subsets and test on the one the left out subset. And I'll repeat this process every time using different subset for the testing. And then I report my accuracy as average of all 10 runs. So this can be done. So say this is one example where we're using 5-fold cross-validation. So if it's 5-fold, then that means I'll be repeating the process 5 times. I'll split my data set into 5 parts. I'll run or train my data set on the 4th subpart, that is your 80% of the data, and then remaining 20 I'll use for testing. And you'll repeat this process 5 times, every time with different composition of the data points, and then you report back average of all those runs. As you can see here, as you increase this degree of polynomial, your cross validation error tends to increase. It was stable for some point of time. That means you can say the good point comes out to be around 4 or 5, where it's more suitable, where you have the least cross validation error. And I can pick that degree that is, I would say, the closest to the minimum value of cross validation error. In this case, I believe it's 4. And if we use the same data points I showed you earlier, and now I check the underfitting and overfitting, now you can see that our the mathematical function that we come out with is pretty close to your true mathematical function. So now you can see that underfitting, overfitting, these problems have been handled, and most of the data points they are pretty close on this curve of what a true function as well as on your test predictions. So to summarize, again, when we want to perform model selection, there are many methods on it. So it's not a good approach that you can just say that I'm going to pick this library as a inline model, and I'm just going to use one model randomly. So it's the best to try different several models, and also to go with the different hyperparameter settings, and then pick something that is suitable for your data set. So something that is say suitable for economics data may not be suitable for agriculture data. And with agriculture, if something is only one kind of sensor, that model may not work for other types of sensory data. So again, you'll have to try that for one particular application. And once you know that, say, this model works for a kind of sensor, next time you're dealing with the data from same kind of sensor, you can use the same model because you have tested various models. You have come up with something that's going to work. So now, before closing this, I'm just going to show you quickly like how we kind of apply something that go from data to get these results. I'll be talking more about these applications and models talk with the biotechnology. But right now, I just want to give you an idea that in reality, you want to go from data and where all my results will look like. So this is something that we call, okay, so just gonna take a second because it's just like that. Okay, so it's going to show you classification problem. And again, as a computer scientist, you don't have to again, if you're working on very sensitive applications, then you will acquire that domain knowledge as you will proceed, as you go with more and more problems from that domain. But as a computer scientist, what you can think of it as you are going to get some data, and all you need to think about is how to come up with feature vectors that you can feed to these machine learning models and then analyze the results. So the biggest problem for you will be how to transform your data from something that is given to you to feature vectors that are suitable or acceptable into ML model. So this is DNA sequence. This is how it looks like. And for computer science, this is just a string of 4-letter alphabet that's ACG numerical. This alphabet string you do not have to verify. Doesn't matter if you're taking it from plants, you're taking it from humans or any other animals. But now, my machine learning model, they'll like numbers because I'm going to come up with a mathematical model. So I need to transform it into some numerical series. It could be one-dimensional, it could be two-dimensional. In this case, again, we have all kinds of transformation techniques that I'll talk about in my tomorrow's talk. So let's run with this is just going to take 1 second. So what this is doing is, this is transforming this into some 2D representation, which is Gaussian representation. Again, that's just numbers in a matrix form that is computing the frequency of different letters. and you just compute the frequency of different atoms in your string. You can get those numbers, and you have those, I'll say, 2D matrix, and those are your feature vectors. You can concatenate those numbers, just concatenate all rows and columns of your matrix, and you'll come up with that 1D vector that you can use as a feature vector. So let me show you what I transformed from that ACGP letter string. So this is what we generated. So you can think of this model as a plot that has ACGP on 4 corners, and we just computed the frequency. So every black dot is telling you that say letter A exists, or letter C exists, or D exists. And once you have these images just a 2D vector, you can concatenate these rows, and then you feed these to your machine learning models. And this is what we come up with. So this data set was birds, fish, and mammals. So you are trying to classify those, and this is what the separation looks like. So you can see this is fairly good. You can see the 3 perfect clusters. Green are mammals, red are fish, and blue are birds. And all are so in the same way, you can apply the same technique. All you need to do is take the agriculture data, then transform into some numerical vector in that form, and just feed to the same pipeline. And these are our accuracies over here for the different models I tried here. So you can see I tried these 5-6 models, and the best one that's looking for me is the discriminant code, which is just a linear model that's going to be the most, I would say, the efficient one in terms of time performance. Space models make a bit lower. You can see the same model. 4 vector machine with different degree of polynomiality that demonstrated degree 1 and 2. And you increase the degree, also increases the accuracy, not just the performance. You can see that this was suitable for most linear models, and you can just go and use the simplest model for this kind of data set. So with that, I'll just recommend talk and then then we can discuss and
Thank you, sir, for your valuable talk on how to apply machine learning on different domains. Now, I would like to introduce our respectable guest, Tarandeep Randhawa. Tarandeep Randhawa is a software developer with IBM Canada. At IBM, she is part of the data and artificial intelligence team. She is currently exploring the use of machine learning to auto generation of SQL queries from natural language to get results from DB2 in real time. Her research interests include computer networks, DB2, and machine learning. I would like to invite Tarandeep Randhawa to present on machine learning in network impact modeling and analysis.
Hi, good morning, everyone. My name is Tarandeep Randhawa. I'm a software developer in all I will find machine learning in network impact modeling analysis. Get started. So you all know the digitization of large data means an extensive growth of internet traffic. You can estimate the network data. Digital data created. Is 4.4.
Sharing visual. Sharing. Stop. Shield. Background.
Speaking स्लाइड शो बॉक्स कम करने चला इससे इसको बड़ा करना
पर्दे के नीचे कीन ऑफ
Let's start with as I already mentioned. The definition of data, the IDC estimated that created, replicated, and consumed was 0.4 gigabytes. But in 2015, 8 gigabytes. According to IDC, both the volume of data will reach or is reaching 40 gigabytes.
Yes, kami para i-recall mo nung naman.
And we all know we have a lot of electronics. Every day, a huge number of devices are being connected into the internet. Total internet traffic has experienced a dramatic growth in the past decade. The number of devices connecting to IP network rises 3 times more than the global population of the country. So if we talk about this massive amount of internet traffic impact on network capacity, which will impact the network quality of service. So that means network health is deteriorating. So there is the quality of service parameters such as there are a lot of latency, jitter, throughput, packet loss, and load time. So if we talk in layman language, when we are talking about have so many devices. Which members only devices, even those are devices there. So more internet traffic is coming, but so that's why internet service is a plan. They need to understand how many houses, like new houses are ready, we need that. That is the traffic. That's why we came up with a plan that we need to generate a framework that will alert the network planner, the internet service provider, that will alert them on high risk so that they can act accordingly, so that we can provide more bandwidth. So if I'm talking about quality of service, it is the service of higher network and user. And various quality of service parameters are packet loss, latency, jitter, throughput, and utilization. So packet loss is when IP packets are unable to reach from source to destination. And latency is the transit time taken by packet reach from source to destination. And in jitter is a variation in delay. That is when end-to-end delay is not constant. And throughput is number of packets processed through the network in a unit of time. And if we talk about the utilization can help us understand whether the network is either normal or busy. So, for example, we have a container, we fill the water, we fill the container with the water, like 60%. That means that container is 60% utilized and 40% is. And load balancing. This is also the main factor that gets affected by the excessive amount of internet traffic. It is a technique where workload is divided into multiple resources in order to prevent congestion, in order to get high throughput, in order to optimize traffic, and on any particular resources. So, for example, this is a graph. Originally, traffic is flowing from the shortest path. With the increase of traffic, it gets congested, and you can see from the red line. So in order to load balance, we reroute the traffic. So we get the longest path, but we get in accurate time. So that's what load balancing. So I'm talking about problem statement. So as you all know, the most growth of internet traffic poses a great challenge to internet service providers. They plan a network growth in a cost-effective manner, which requires quality of service. So what we are doing in our framework, we are simulating a network G with a traffic pattern E. So we are passing up front traffic and we are calculating quality of service. Again, then we pass the forecast traffic, what amount of traffic, again calculating quality of service. We are comparing them. And then we check which are the high risk links, which will help the network planners plan for the future. So this is some of the related work I did, and then with the flow chart that outlines like my methodology, that is network impact modeling analysis. In short, NEMA. So we create a network topology and initialize the network simulation using a floodlight controller. This model takes two traffic passes, pass 1 and pass 2. In pass 1, we pass the current traffic and quality of service parameters are evaluated. This model uses REST API interface of floodlight controller to control various quality of service parameters. It stores these parameters value for data comparison, and in pass 2, we pass the forecasted traffic to the same network setup. Quality of service parameters are again evaluated. A comparison of quality of service front and forecasted traffic is done to analyze the traffic impact on the network. We use machine learning model to perform this analysis. Feature vectors were created by concatenating the values of quality of service parameters. Labels were assigned based on their impact on net. Multiple machine learning models are trained using these feature vectors. Then trained models can be used to predict the model for forecasting. Now we talk about the layout, how we simulated the network. We considered both partial and full topologies in order to come up with the real world scenario. The network is a combination of full and partial mesh topology. We use 5 different sizing topologies having a difference in number of nodes that are interconnected as a full mesh and partial mesh network. So this is a topology 1 in which there are 5 switches, each connected with 5 nodes. Similarly, in topology 2, there are 10 switches, each connected with 10 nodes, and so on. And then we create, use a traffic generation ICMP and TCP window size of 8500. So if we analyze the result, the link color shows the utilization status. So green for utilization less than 50%, that is okay status. Yellow for utilization between 50 to 80, and red, that means there is a danger zone, utilization is 80% with failed status. Similarly, in forecasted traffic, when we pass more traffic, then we see from S1 to S2, utilization increased by 81%. Then in order to do this, we use GAMS algorithm that uses 3 shortest paths. Instead, like Vesta, we uses only one single shortest path, this uses 3 shortest paths. And then we calculated for example, because for topology T4, if we pass the traffic from the shortest path and then we calculate throughput, jitter, and packet loss. And same we did with the forecasted traffic, and we calculated all 3 things. And we saw that throughput increases by 349 Mbps and packet loss increases from 5% to 8% when we pass more traffic to the same network. Then these are some of the results that we use, that the average throughput increase for forecasted traffic when compared to current traffic by 296 Mbps to 349 Mbps if we are using full mesh topology. Similarly, we benchmark link status like OK, warning, and fail signals, and it is found that link utilization elevated for forecasted traffic, almost following the same pattern. So utilization based change in link status. So when the traffic is not that much and topology is small, there is no loss. So all things remaining 100%. So everything is fine. But when we see change in utilization, there are 10% links that are changing from warning to fail. And if we are comparing overall link utilization went up for forecasted traffic because of an increase in network traffic. And then we check the comparison of average latency, and average latency also increases from 14 milliseconds to 26 milliseconds. There is increase in jitter as well as there is increase in packet loss as well as when we compare the traffic with front traffic and forecasted traffic. Then we check load balancing value. So this slide is showing load balancing percentage for current traffic, which we are using single shortest path routing using di-cluster algorithm and forecasted traffic using multi-path routing algorithm. So this means more the MVP value, more equally distributed traffic, and it is seen that multi-path routing improves the load balance. The same way that we compare the load balancing algorithms using latency, throughput, and load balancing value, and we check that YAML algorithm outperform all other algorithms. So in the last summary, so what we discussed, throughput increase for forecasted traffic compared to front traffic, link utilization is elevated for forecast. So this auto updates the statics for the internet service providers and raises the flag for troublesome links. Highly utilized links show an elevation in latency, jitter, and passing forecasted traffic. More LVP value means more equally distributed traffic, and multi-path routing is more advanced. Thank you.
Thank you, ma'am, for valuable information. I would like to request the Vice Chancellor, Professor Dr. Kamruzaman, along with the Director, Professor Dr. Yasir Hafiz, and Director for the Directorate of External Linkages, Dr. Sakti Majid, and Managing Director, Mr. Muhammad Umar Chaudhary, for signing the MOU between the University and DICE and elections. Pro Vice Chancellor, please.
Hello everyone, I am Dr. Mariam Muzammil. On behalf of UIIT, we are thankful to the worthy Vice Chancellor and honorable guests taking out the time to attend this workshop. Our sincere gratitude to Office of Research, Innovation and Commercialization, ORIC, for supporting this event. Now it is time to acknowledge our respected guests. I would like to request worthy Vice Chancellor, Professor Dr. Kamruzaman, along with Pro Vice Chancellor, Professor Dr. Fiyazul Hassan Sai, and Director UIIT, Professor Dr. Yasir Hafiz, to please come over and present the certificates, shields, and souvenirs. First of all, I would like to invite Dr. Gurjeet Singh Randhawa to please come and receive his shield and certificate from the Operator Vice Chancellor. Thank you, sir. Next, I would like to invite Dr. Itazaz Hassan Farooq to please come and receive his shield and certificate. Thank you, sir. Next, I would like to invite Taranjeet Howard. Please come and receive her shield and certificate. Thank you, ma'am. Now I would like to request Honorable Vice Chancellor to receive the sheet from Director UIIT, Professor Dr. Yasir Hafiz. Now I would like to invite Mr. Muhammad Umar Chaudhary to please come and present the sheet. I would like to call Dr. Yasir Hafiz to receive the sheet from Mr. Muhammad Umar Chaudhary from DICE Analytics. Thank you, sir. Next, I would like to call Dr. Muhammad Saqib Majid to please receive the sheet from Mr. Muhammad Umar Chaudhary. Thank you, sir. Thank you, everyone. I would like to request the worthy Vice Chancellor, Pro Vice Chancellor, Deans Directors, and Honorable Keynote Speakers to please proceed to the meeting room. I request rest of the participants please remain seated. Ladies and gentlemen, we are going to continue the sessions of our next guest speakers.
Artificial technology. Now I would like to introduce our respectable guest, Mr. Muhammad Umar Chaudhary. He is managing director of DICE Analytics and Euretics. Along with this, he is also member of advisory board in NIST Islamabad. He has been part of the industry since 2009, experiencing lot of trending technologies include data science, big data, business intelligence, artificial intelligence, and blockchain. I would like to invite Mr. Muhammad Umar Chaudhary give his talk on use of artificial intelligence for upskilling and employment of young talent of Pakistan.
Sure.
हाँ यार तो माउस लगा ना ये वाला ले ये लगा कौन से ना ये दूसरा नहीं लगा तो ये नहीं है टेंशन तभी साइड में होगा मैंने दिए जाएगा अब क्या हो सकता शेयर नहीं कर रहा शेयर यहाँ से करवा है वहां से लोकल करे यहाँ से शेयरिंग कितने नहीं ये सेशन में शेयरिंग की उस पर तो चल रही थी उसको दिया हुआ लगा हुआ है ना
छोटा बना नहीं
अब तो हेलो ये घुमा देते ना क्या करूं बीच में लगा हुआ तारा तो कहाँ किया
लगाओ पीछे वाले
कहाँ की है मुझे क्या पता है बीच के लिए एक चीज भी है घुमा दी निकालिए तो जेब में देखो दाएं बाएं
देख लीजिएगा स्लाइड शेयर हो रही है
और ये
नहीं भाई करना है उसके बाद
यार ये वाला लैपटॉप लगा है रूम लगने कनेक्टेड है उधर लगा है शुरू में ठीक चला है बाद में वह चीजें घुमा दी है लोग शेयरिंग पता है क्यों नहीं होता जब आप उसको जूम से लेके आते हैं ना तो उसको जूम के साथ शेयरिंग करवाना फिर होता है आगे आप
कुछ साथ की यूएसपी डिलाइव कलर के वो मांग रहे हैं तो बात बस बढ़िया है तो कर लो टक्कर दे
Basically is built for upskill and employ the youth, the young talent of Pakistan on a remote work model. So NiceCamp is a good product. It is a brand of Nice Analytics Private Limited, of which I'm the co-founder and managing director. So the slogan is helping Pakistan transform into a global destination of tech professionals. So थोड़ा सा मैं पहले product के बारे में बताऊंगा. So problem that we are addressing is basically number one, it's twofold: a lack of awareness and employable tech skills among the 63 million youth of Pakistan, is basically leading them to joblessness and financial instability, and ultimately the whole country into economic crisis. The second problem is basically the global problem, which is basically the demand of tech professionals is increasing, but on the other side, it's creating a tremendous shortage of supply, and therefore it's increasing the cost and time of hiring on the employer side. So the solution that we are basically working on this for, so it's basically DiceCamp, which is a gamification and AI-powered platform that leverages skill seekers, professionals, industry, academia, in order to upskill youth of Pakistan on industry-demanded skills, and secondly, provide IT pre-vetted resources globally on remote work models. Sorry, I have to just go back again and again to switch the slides. So before I move further, I just want to share some of the traction so far that we have been able to achieve, and how AI has actually helped us achieve that. So that's why it's very important to share that. So far, we are the #1 AI training company in Pakistan, and we've got about 60,000 subscribers, 7,000 people trained and vetted so far in the last 5 years. 90% is the job rate through our bootcamp, training bootcamp. On the recruitment side, we've got about 97% engagement success rate, 7 days to fill most roles, and 50 plus hours of engineering team time saved. Overall, we've had so far about 137 companies that are local and international branded. A glimpse on the training programs that we offer. As you can see, all of them are high-tech skills. So the screen is visible to the people sitting at the backside. So here's a glimpse at the training products that we have, the bootcamp training programs designed by the industry and for the young talent of Pakistan to upskill themselves and obviously to fill the gaps of the highly demanded skills. So as you can see, there's data science, there's big data, cloud computing, deep learning for artificial intelligence, and the list goes on. Few of our noble corporate clients, because we also work with corporate sector in upskilling their resources for corporate trainings. So we work with overseas organizations, telecom sector, armed forces, government, banking sector, healthcare. So all of these sectors we work with already. Job placements where our alumni of bootcamps are currently working. So here are a few of the notable clients. You can see Teradata, IBM, and such kind of organizations. We have already partnered with the top universities of Pakistan, for example, GIK, NED, NASC, SEED, FAST, ComCert, UET, and so on. And today we are honored to have partnered with Arab University. So how does this DICE camp framework work? How are we basically upskilling and have been able to teach 7,000 people trained on this model? So it's a 5-step framework. Step 1 is set your track and you come as a skill seeker, as a career seeker. So first of all, we help you setting your career track because it's very easy to get confused when you're fresh graduate, you have done a computer science degree program. There's so many branches in front of you: cybersecurity, DevOps, full stack development, data science, engineering. So first of all, set track is basically the step. It's a module in the DICE camp, which fully leverages artificial intelligence to basically advise you on which is the right career track for you, which I'm going to explain further in the upcoming slides. Once you've set your track, your career track, the second step is acquiring the skills. Now you know which career track you want to follow. For that, you need to acquire your skills. So which skills you have to acquire, in which format, and then eventually, to what level to land your first job. So all those things are covered here, and this is where our training program comes in. The second thing is the networking, which is the most important thing, building your network and being at the right place at the right time. So we do a lot of meetups, we do a lot of hackathons and jobathons, and we also do rockathons. And we have done about 120 plus seminars so far. More than 30,000 people have attended all of those seminars, and all of them are free of charge, just to create awareness on the tech skills. And the fourth step is basically getting yourself evaluated. Now you have set your track, you've acquired the required skills, you have connected with the right people. Fourth step is now you have to get yourself evaluated by the industry experts. There's an evaluation process where we pre-vet you and make you job ready for the employer to onboard you. So finally, fifth step is basically finding work. When we stepped into the industry 5 years ago, the reason why we stepped in was everybody was directly going to the fifth step instead of just passing through all these first 4 steps. So this is how we actually are addressing the challenge and fulfilling the gaps. So once a candidate gets pre-vetted, this is how his profile looks like in front of the employer. So the employer can see 4 areas: your resume, your communication skills, your hard skills, and your seniority level. So all these 4 areas, they get a full-fledged, summary report first of all, and then they can dig down deeper. For example, if they want to see, okay, they're being ranked at, in communication skills, this candidate is ranked at great. So I want to see how DICE camp has, ranked them great. So he get down deeper into the video interview because he can also see the video interview online that we conducted that were watched and conducted because we have a bot that basically conducts your communication skills interview and it checks basically 5 different areas. And then we have, seniority tests. And then for the hard skills, yes, this is an area we are working on. We would love to collaborate with our university on this. That when it is live coding challenge, which is actually being monitored, being conducted by university professionals, and then there is a technical interview. So this is done still so far. This is done manually. So far, we've been able to automate communication skills interview. So that's my last slide, by the way. So there are 6 use cases, which is basically empowering this price impact for upskilling and employment. So as you can see, number 1 is basically career track advisor. So the step 1, which I talked about, which was set track. Set track basically, what we used to do previously, we had advisors. We had in-house advisors that used to provide free advices to people who were seeking for career advice. But we could only do so much because there are a lot of people seeking for advice. That's why we just automated all that. So what we did was we used Myers-Briggs test, which is a famous psychological test, which tells you which career track in general you can be in. And then we blended that with about 55 other data parameters from the resume of the user, from the interest level, and all this. And then basically this model predicts and suggests what could be the right career track for you. Can you be a successful data scientist, or should you be a full stack developer? Or maybe you should go into certified ethical hacking, ethical hacking or cybersecurity. So this kind of stuff this model is working on. And the second use case that we have deployed here is learning path builder. So yes, now you know that which track you want to follow. But the next most important thing is that okay, if I want to be a data scientist, what steps I need to take? What is my roadmap for the next 2 years? So this model basically predicts and forecasts and suggests what basically are going to be, what steps you need to take on a monthly basis, weekly basis, which certifications now you need to do, which workshops you need to perform, which projects you need to do on Kaggle or Kaggle. Then which relevant internships, what sort of organizations, which sectors you need to do. So it builds your whole roadmap, and then until you land the first job. But the story doesn't end once you land the first job. The skill development continues. So you come back to the step 2, which is acquire skills, and you keep improving your skills. You just further upgrade yourself and go further in your career track. Third use case is the exam proctor, because when we do the evaluation, it's a 3-step process. It's tightly pre-vetted and rigorously evaluated for evaluation process, where we basically first of all we do the MCQ test. Let's say if somebody says that yes, I rank at this level, I'm a 4 years data scientist, and we say okay, let's take a test, let's take an evaluation. So first of all, he has to pass that skill test. He has to score 90% in that. That skill test is basically MCQ based test. Usually what we saw was people, we have seen this challenge in academia as well. Unless there's a human being standing in front of the exam, and especially in COVID, we saw that a lot of gets misused online ability and facility quizzes and exams. So exam proctor basically what it does is it captures the screen movement, and also the camera has to be turned on. First of all, it does a facial recognition and verifies if it's the right guy sitting and performing the exam and giving the exam. And secondly, it also captures the eyeball movement and features throughout the exam, because the candidate has to keep his camera turned on. The fourth use case is basically interview bot. This is what I was talking about, the communication skills interview. This bot checks, takes your interview for communication skills in English and checks 5 different areas. And one is, what is your confidence level to the computer vision? Number 2 is, how fluent you are in speaking English. How good is your vocabulary? How good is your grammar? And number 5 is the accent. Because it's remote work model, so when you have to work with an overseas client, English is the key. Doesn't matter if you don't have good skills. I mean, your skills are average, but your communication is good. That's gonna cover up the skill gap. So the requirement that we get from overseas employers is mainly concerned about the communication skills. So this model that we have built is basically addressing the challenge, and we are improving it day by day. Machine learning, artificial intelligence, you're always basically just retraining, building and retraining and doing that stuff. So yeah, it's getting improved day by day. Fifth use case is resume scorer. So one thing we have to learn, a lot of people are sitting over here listening to us online. They might be, in their final years, or about to graduate or fresh graduates. So resume, there's one rule of resume, that there shouldn't be one resume. You have to build multiple resumes for the different sectors. So you are just building one resume and then you are sending it across each organization, which is not the right way. You have to customize your resume, the context of the job description and the sector of the organization. So initially we provided manually a lot of resume guide to improve their resumes, and that's where we were generating a lot of data. And then we built a resume parser. Doesn't matter what kind of resume you have, Word, PDF, whatever format, unstructured format. So you just upload your resume and then we just bring it into our structured format. That was just step one. And then when you apply for a job, for a particular job, it scores at how much your resume is relevant to this job description. For example, you're applying for a data science position in healthcare. So you need to modify your cover letter. You need to use the healthcare jargon. You need to mention that yes, you have studied HL7 standards and stuff like that, just to convince them more. So such kind of suggestions are basically coming in, and using those factors, it suggests and recommends that what kind of improvements you can do in your resume for this particular job description. Finally, the sixth and the last use case that we have developed is JD candidate matcher. The same challenge is on the employer side as well. They're not able to express their requirements properly in the job description. What kind of people they need, or they forget to mention the right tools and the skills they are looking for, which wastes a lot of time of the candidates. So when an employer uploads their job description, this is where we actually suggest through this AI model what kind of improvements you can do. And first of all, it brings that into structured format. It extracts the skills it requires from the plain description, and the career track and the sub-career track, all that stuff is extracted. And then what kind of experience is looking for, because usually employers don't bother. They just, there's one job description and they just try to spread it everywhere on all those folds. So previously what the challenge we were facing was we had to manually call the employer, for example, phone or organizations that are hiring with us. We have to call them manually that yes, you have to restructure your job description so you can get a better match of the candidates. But then eventually we just use that data, that past data, and eventually build a model, which is performing pretty well and saved us a lot of time. So this is basically the final product of Zyscan. This is what employers need. This is what is highly in demand in the world. That employers are looking for talented people, which are fully vetted and fully evaluated, and they just simply onboard them within 5-6 days. And using of machine learning and artificial intelligence has really helped us to speed up the process of taking candidates to this level, and also increasing the volume of pre-vetted people. Otherwise, it was going very slow. So that's all from my side. Thank you very much.
Very much, sir. Now I would like to introduce our next speaker, Dr. Shrey Vasa from Aalto University, Finland. Dr. Shrey received his PhD from Guangzhou Institute of Science and Technology, South Korea. Later, as a postdoctoral researcher, he joined Machine Learning Vision Lab, Guangzhou Institute of Science and Technology, South Korea, where he worked on developing applications using deep learning for autonomous driving and robotics. His research interests include deep learning, autonomous driving, sensory motor learning, and representation learning. I will request Dr. Shrey Vasa to start the online session on system design and experimental validation of autonomous vehicle in an unconstrained environment.
कहाँ से आ रही है आवाज? आ रही है आवाज? हमारी कहाँ से आ रही है?
Thank you for the introduction. So, can you please allow me to share my screen?
क्या करूँ?
Yes, sir, you can share the screen.
Okay.
क्या हुआ?
Is
We
my
can see your
screen?
screen now.
Okay, thank you. Good morning, everyone. So, thank you for the introduction and inviting me to giving a talk on system design experimental validation of autonomous vehicle in constrained environment. So, basically, my talk will be how the application of artificial intelligence, or specifically deep learning, is applied in the field of robotics, and my work in the field of robotics on autonomous driving. So let me start my presentation with this brief demonstration of our autonomous vehicle, which is fully functional in our campus. And it includes a couple of modules, which I will explain later in my presentation, and how this working of autonomous driving is performed in our campus. So basically, I will explain what is the vehicle platform which we use for our autonomous driving, and what type of architecture we develop for autonomous vehicle, and then finally the modules which are necessary for operating this autonomous vehicle functionally, which is mapping and localization, how perception is done with the help of deep learning, and then planning and control. And basically in control, I will explain first the classical approach which we use for our autonomous driving, and then we develop a neural network controller which takes the input from the planning, and then with the help of deep learning, it gives us the final values that we inject to the actuators. And then whole this system is experimentally validated for autonomous taxi service, which is currently running in our campus. So so this is the autonomous vehicle platform. We use Kia Soul EV and retrofitted it with exteroceptive sensors and proprioceptive sensors. So in exteroceptive sensor, we use LiDAR, which is basically 32-channel LiDAR, and then RGB cameras along with radar, which is used for getting the information from environment. And then to help with the navigations, we use proprioceptive sensor, which include GNSS, which is the combination of GPS and IMU, which give us the orientation and position of our vehicle in the environment. And then CAN bus controller, which give us the vehicle actual drive pedal, brake pedal, and steering angle commands. And we use to transfer those throttle, steer, and brake command to the actuator of autonomous vehicle. And then there is an electronic controller which we use as a safety purpose if somehow the vehicle doesn't perform along the course of action. So we just use that electronic sensor as a safety measure, and then the driver just pedal on the brake pedal, and then the vehicle turn into manual control. So this is just for the safety. And then this is a wiring diagram. This is a high level abstract of wiring diagram which we use in our autonomous vehicle. So basically we have used an inverter which converts DC signal into AC signal, and then we have couple of computational units which we use, for instance, LiDAR cameras, and we have a main server for which is basically computing the deep learning methods for perception, and also for our control for the neural network controller. So another, to be more precise, this is just a high level abstraction semantic diagram of sensor communication, and we adopted a distributed computation architecture for our autonomous vehicles. So our main server receives the signals from the cameras, and then there are two Raspberry Pi which we serve as a distributed component, which one distributed Raspberry Pi is communicating with the drive kit, which is an electronic controller, and then another Raspberry Pi is communicating with the GNSS, and those two signals are then transformed to the main server or a Wi-Fi router. So why we use a Wi-Fi router? Because we built an internally autonomous vehicle framework. So this was best suited for us. And basically, we were using ROS, robot operating system, which is just a middleware on the top of another operating system. And because we use ROS, there is an advantage of the ROS because it has some plumbing tools, and it has better communication and better scalability for the robotics applications. And then for the LiDAR, we just broadcast LiDAR signal over the Wi-Fi, and these are received by the main servers. So, and those in the ROS, all the signals are asynchronous, so we are just getting whenever. So basically, in ROS, there is something node. So whenever we need some signal, it receive those signal and then perform some computation and then give us the output. So this is a brief architecture of autonomous vehicles. So there are basically 4 layers. So one is sensor layer, in which there are exterior and proprioceptive sensors, and then there is a perception layer. So we divide perception layer into 2 main parts. One is localization, which is very important for the autonomous vehicle to decide where it is located in the environment. And another one is the perception. And in perception, we use deep learning based solutions for image and also for the LiDAR. And then those information are passed to the planning layer, in which we use motion and mission planning. So motion planning is basically a local planner, which involves the behavior planning for autonomous driving. And the mission planner is basically a global planner. And for global planner, I mean that we give a global route to the autonomous vehicle, and from certain point A to certain point B, which is helpful for the autonomous vehicle to move along that course of action. And then after planning, we get trajectories and velocities, and these optimal trajectories are passed to the control module. And in control, there are 2 lateral control and longitudinal control. And after that control module, we get the final output of throttle, brake, and torque, and these are passed to the vehicle actuator through drive kit. So basically, in all autonomous vehicle, there is a bus which we call CAN bus. So this is controller area network. So that communicates between different modules between the vehicles. So we use that CAN bus as a like main source for communicating between vehicle actuators and our software stack. So let me talk first about mapping and localization. So there are 2 kinds of mapping and localization algorithms. So one is SLAM, which is simultaneously localization and mapping. Another one is prior map based. So we adopted a prior map based approach, in which the first map is built using normal distribution transform mapping using the LiDAR data, and then these point cloud is downsampled using voxel grid filter, and along with this final normal distribution 3D map, we use normal distribution and transform matching, which receive filter point cloud data along with GPS, IMU, and odometry, and then it gives us the pose and velocity for localization of autonomous vehicle. So basically, it's just we have the 3D map, and we try to match the filter point cloud data on those 3D map and find out the pose and velocity for localization. So this is brief results of point cloud map which we built for our campus. So this map is built using LiDAR data along with GPS, IMU, and odometry information. And using this 3D map, we do the localization of autonomous vehicle on this pre-built 3D map. So that give us the estimate, or that give us the estimated position of an orientation of our autonomous vehicle inside that environment, which we built using LiDAR data. So if there is any question, please feel free to interrupt me. And if there is any problem with the presentation, yeah, please feel free to interrupt me. So then there is perception modules. In perception module, we use both image camera and LiDAR for getting the perception results. So this is overall architecture of perception module. So it includes the object detection for both for the camera and also for the LiDAR point cloud data. And then we use those detection results for calibration of camera and the LiDAR, because we want to project. Sorry. Okay, so we project those calibration results in the LiDAR frame, because this is kind of our world frame and our autonomous vehicle in that world frame. So the reprojection module consists of range fusion that performs the distance calculation from point image, which we built from the LiDAR point cloud data and object detection proposal in images, and then finally computes the object labels, bounding box in the LiDAR frame. So in the next slide, I will show the results which we use in the perception using deep learning frameworks. So for segmentation, we implement SegNet, which is very popular deep learning framework in the ROS framework, because everything is working on the ROS framework. So it is not just like PyTorch implementation. We have to apply some optimization techniques using TensorRT and then use that framework in ROS environment. And the video on the right side is basically object detection using the YOLO network. So this is just implementation of YOLO. And then we try to find the lanes in our environment. So we just use the lane detection network and segment the lane information from the environment. So this is the perception module is basically just the deep learning application of different algorithms which we tried, but like SegNet and YOLO give us the best results in our experimentation. Similarly, for the because I have mentioned that we use both image and LiDAR in the perception module. So for the perception in using LiDAR data, we have implemented point pillar network, which is just taking the point cloud and then convert those point cloud into a pillar feature network. So this pillar feature network is just like a pseudo image of point cloud, and then this pseudo image is passed to a pre-trained backbone 2D CNN, and then we on the top of that we have a detection head which tell us certain objects in point cloud data. So on the left side there is a demonstration video of point pillar network in action for detecting objects, mostly cars, in the environment. So these are just the calibration results of image data and LiDAR data. So for the image, we use classical open PNP method for detecting the corner points, and then for the LiDAR point cloud data, we just take the help of manually select the checkerboard, and then we project those checkerboard which is selected in the LiDAR image to the image frame, which give us the point image. And then those point image is then projected back to the LiDAR frame, which is just like we use the multiple view geometry concept of projecting the 3D object into the 2D and then check if it is just matching above the 50%, then we project those 2D image into the 3D environment. So now in the planning, basically we have two kind of planning, which is very helpful in doing the planning for autonomous vehicle. One is mission planning, which is serve as a global planner, and we use rule-based planner in which we get the lanes information and all kind of lane information. And then there is a motion planner which serve as a local planner. In local planner, we perform trajectory planning and behavior state generation. So for the global planner, we give the autonomous vehicle a start and the end goal. And using those start and end goal, mission planner performs the trajectory optimization and then behavior state generation for autonomous driving. And after getting optimal trajectories, these optimal trajectories are passed to the control. And in control, we have lateral and longitudinal control. So this is just a demonstration of autonomous vehicle. So performing obstacle detection and avoidance by applying the traffic rule. So we just place mannequin of dog as an obstacle, and then autonomous vehicle avoid that obstacle by complying the traffic rules. And on the top right, there is the software stack which we are using and showing that the trajectory is avoiding that obstacle. So these are some quantitative evaluations of obstacle detection using our autonomous vehicle. So the figure B shows profiles of speed, brake, and obstacle. So whenever obstacle is detected, the brake is applied and speed is lowered down, and then obstacle detection profile shows that yes, the obstacle is detected. And same goes, we tested with like a person or any other objects if we find along the course of action. And similarly for obstacle avoidance, we see figure C shows and figure C shows the profile of speed, brake, steering angle, and obstacle detected. So the most important in this is that in the previous there is no steering angle profile because we are not avoiding an obstacle, because this was a single lane and there is no information of other lane, so the autonomous vehicle just stopped. In this case, we have available option by going on the right side, and we cannot move on the left side because it is against the traffic laws. So there's a steering profile which shows that the autonomous vehicle will move on the right side by projecting the angle on the right side. And if we have some other information, like if we can go on the left side, then the steering profile will be on the lower side. So this was like planning, and after getting all the optimal trajectories, we pass those trajectories to the, we develop a PID controller, which we call KSO socket. So it composed of different PIDs for throttle, brake PIDs, and torque PIDs. And then after those PIDs, we give the commands to the drive kit. So for the longitudinal control, we have experimented with two main approaches. So first one is the classical Cohen-Kuhn method for training the KPK and KD parameters for PID controller. And the other one is because in Cohen-Kuhn method, there is a manual supervision by human, and we have to manually adjust the KPK and KD parameters for every time, and we have to optimize it manually. But this was the problem, so we use genetic algorithm to tune the parameters of KPK and KD parameters for autonomous vehicle. So these are some quantitative analysis between controller parameters for KPK and KD using Cohen-Kuhn and genetic algorithm for throttle and torque. So for the genetic algorithm, we find pretty much good results in tuning those parameters. And these are the profiles which we get after tuning the parameters using genetic algorithms for steering angle and also for the throttle and brake PIDs. And then finally, lateral control. In lateral control, we use we experimented with two main approaches. So first one is the pure pursuit, which calculates the curvature from current position to some goal position. and basically it is based on a look ahead distance. So it pure pursuit chases a moving goal points, so some distance ahead. So we solve that. It's basically classical by solving two right angle triangles and then find those look ahead distance. So basically look ahead distance is the main parameter for this pure pursuit. So, and the other one is the model predictive controller path follower. So in this, we just have the model and we give the past inputs to the model and reference trajectories, and then we get the future errors and optimized with the help of cost function and constraints to get the optimal inputs for our autonomous vehicle. So these are some quantitative results showing the effect of look ahead distance using pure pursuit. So we have tested with very long distance, like if we put 20-meter pure pursuit look ahead distance. So it was very much disturbing and over it was under very vibrations in the autonomous vehicle. And if we put 1 meter, which is very near to the autonomous vehicle, so we get a lot of noise in the planning of autonomous vehicle. So for our experimentation, we found that 6 meter is the optimized distance, and it produced better results in moving the autonomous vehicle. And similarly, this is the comparison between the pure pursuit and model predictive controller path follower. So when we tested with the model predictive path follower, so it was much more optimized and showing better results in driving the autonomous vehicle as compared to pure pursuit. So pure pursuit on the curved roads was overshooting, but the model predictive control gave us the better results, which we compare with our ground truths. And because the problem with the previous classical control is that it is manually we have to manually train, and we have to optimize it with certain driving conditions. So this we develop a neural network controller design using behavior cloning. So basically the conventional pipeline for motion planning to actuator is using classical control like PID or MPC, but we develop a neural network controller design which take that path tracking algorithm. So from the path tracking algorithm, we get the linear and angular velocities, and on the basis of that, we design a neural network controller which give us the throttle, brake, and torque values, which then pass to the actuator. So we develop a simple 5-layer LSTM architecture which gets the CAN data in the form of velocity and steering angle, and then using those data, it gives us the final output in the form of throttle, brake, and torque prediction. So the question is why we use a simple LSTM, because it was not computationally not computationally heavy for our ROS framework, and it is we have to transform into the ROS environment. So we just use multi-layer LSTM architecture. There are other options which are available, like we can use transformer architecture, but it is like computationally expensive to for our autonomous vehicle. So these are the demonstration of neural network controller design with we tested with the path tracking algorithm, which I explained earlier, like multi-predictive controller. So this is just the neural network controller plus the multi-predictive controller based path follower. So because we have to test it with some path tracking algorithm, whether it is give us the better performance or not in contrast to the classical controller. So this is just the demonstration showing we implemented the neural network controller with MPC based path tracking algorithm. So it is not like it just in the demonstration it just showing the trajectory, but in real it was like not too much disturbance in the autonomous vehicle. In the later slide, I will show the comparison between because we tested neural network controller with MPC-based path tracking algorithm and also with the pure pursuit. So in the next slide, this is basically the demonstration of pure pursuit-based path tracking algorithm with N2C. So, and the whole stack is like the whole stack of autonomous vehicle is working like localization and perception, but on the control and planning side, we just use the neural network controller. Okay, so this is like the comparative analysis between pure pursuit and MPC-based path follower when used with neural network controllers. So the white dots are just the ground truth waypoints. Basically, waypoints is just the information which we give to the autonomous vehicle from start to end, and it includes the information of pose and velocities. And the red shows the pure pursuit waypoints, which we get from when we use it for neural network controller. So on the curve roads, there is a much difference between the pure pursuit waypoints and MPC-based waypoints when used with the neural network controller. So these results shows that when we use neural network controller with MPC-based path follower, it gives us the better results. And finally, these are some edge cases or test scenarios which we tested whole architecture on entry and exit barriers, like if it is detected by autonomous vehicle or not using perception module. So the autonomous vehicle stopped at the exit barriers, and when it allow us to move in, so the autonomous vehicle will complete its course of action. And similarly, we tested the another experimentation with our lab member is facing in front of the autonomous vehicle, and if the vehicle stopped or not. So it was perfectly stopped, and basically obstacle detection and is performed successfully along with localization and perception module. And the final we implement or we develop a cab booking service for our autonomous vehicle. So we develop a server on the customer side. We use Amazon E2C service for this one. We develop an app. On this app, the customer sends the request for the autonomous vehicle, and by giving his location and also the destination location. So because this is a communication between ROS and non-ROS system. So because our autonomous vehicle was using the ROS system, and this app is using a non-ROS system, just like Android application. So we communicate between the server, which is receiving the request from the customer through a ROS bridge server, which communicates the GPS location of our autonomous vehicle and also receive the customer request. And then we develop another web application inside our autonomous vehicle, which acknowledge that if the request is successful, which sent by the customer, and also shows us the customer location. So we just use the existing architecture of our autonomous vehicle, just change a little bit on the customers for the receiving of customer location. So we develop a JSON to ROS node, which converts JSON information from which the customer is sending from its app to ROS messages, and then those ROS messages pass to another node, which we call it cab GPS to TF pose. Basically, it converts the ROS message of GPS information of customer to pose information, and then we get the pose information of customer, and also we have the information of our autonomous vehicle. So we perform all the overall structure of localization, perception, and planning is same. Just we change for accommodating the customer location inside our ROS architecture. And So basically, if we get the goalpost of our customer inside the environment. So we search it in this map in 10-meter radius, and if found, then we do the planning, and the autonomous vehicle reach to its destination. And if it is known, then the searching radius increased by like 5 meter. And if we don't find after like 30-meter radius, or we just make a threshold that if it doesn't found the customer location inside the 40-meter radius, then we just cancel, or we just send the message to the customer that we cannot find the location of you. So these are just snapshots of performing the autonomous taxi service in our environment. So customers send the request, the autonomous vehicle reach to its location, and then using its destination location, the autonomous vehicle will go to that destination by performing all the perception, planning, and control module for the autonomous vehicle. So, so what are the takeaways from this presentation? So I tried my best to explain everything on the modular architecture of autonomous driving. So basically, we use modular architecture for localization, planning, perception, and control. Then there are another end-to-end learning driving policies. So I touched that with neural controller design, because we use some kind of this application for end-to-end learning driving policies. Then a part of this autonomous driving can be improved by using some better representation learning in the form of for the LiDAR and camera images. So this is an open problems in representation learning, and those open problems and challenges can be solved and applied to autonomous driving. Then another important area for autonomous driving is V2X communication. Like we have a cloud server, and there is vehicle to vehicle communication, vehicle to person communication, or vehicle to infrastructure communication. So these are some open challenges which I think can be interesting to solve those problems in the domain of autonomous driving, and applying the application of artificial intelligence, basically deep learning, or like reinforcement learning, or any kind of learning methods to the application of autonomous driving. So that's all from my side, and thank you for inviting me and allowing me to give a short talk on the my current research that is being done on autonomous vehicle. And now, if you have any question, or any suggestion, comments, I'm open to all those comments and suggestions. Thank you so much.
Thank you very much. Ladies and gentlemen, this session has now come to an end. The next session will start at 1:35 p.m. All the participants are requested to assemble here 10 minutes before the start of the next session. The organizing committee members and respected guests from Dice Analytics are requested to proceed to the meeting room. Thank you very much. All the faculty members.
My
as well.
button होगा. YouTube पे कैसा रहा जी? अल्हम्दुलिल्लाह बहुत बड़ा और ना जी कैरी साहब मैं मेन टाइम पे ही नस गया है ना, लेकिन मेरी जगह तो बंदा तैयार थी. आपको देखो शर्मिंदगी नहीं हुई ना, इधर क्या था बंदा पहुंच गया कम है. फिर सिवाय विलसा ऊपर किसी को नहीं पैसा किसको बाकी सारे
लाइव स्ट्रीमिंग अभी बंद कर देना, घंटे बाद स्टार्ट होगी. ना कैसे करूँगी? ठीक है अभी बंद कर.